Backtracking in a maze. In this video we will see how backtracking algorithm works in a maze. So let us start with what is backtracking. Means just what it sounds like. In some problem, as we reach for a solution we may reach a dead end and have to go back. On conceptual level, backtracking is really easy to understand. Anytime you have a problem that is solved by series of decisions, you might make a wrong decision, and when you realize that you'll have to backtrack to a place where you made a decision, and try something else, that's all backtracking really is. Here is an example of finding a path through the maze from start point to the finish point. Anytime you have a choice to where to go, you just have to make a choice, and hope it works out. If it doesn't, you reach a dead end. When that happens, you have to go back to a place that has other paths you haven't tried, and continue from there. Backtracking. Conceptually simple, but that doesn't make it easier to implement in a program. How to implement it in a program. Finding a path through a maze. How do we define a maze in code? There are many ways to define a maze in code. Here is what we are going to do. We will have grid of points where each point is identified by a number. For each point there is list of numbers that are the points that this point connects to. So in this example, point 0 is connected to point 1 and 3. Here is the full list. Let us understand the working of the code. We will maintain two arrays. First one path array and second one visited array. Path array maintain a list of numbers of the points from the start to the current position. Visited array will maintain a list of numbers of the points we have visited but left because they were a dead end. We will see further more clear how these both arrays will work. Algorithm. If destination reached, print path array. Else, add current number in path array and visited array. Move forward and recursively check for solution. If move doesn't lead to a solution, check another path that is backtrack. Constantly modify the arrays, that we will see with an example. Pseudocode to solve the maze. Using the function we are recursively checking for the solution. First we are checking if we are at destination, then condition to check if we have reached in dead end. If yes, we are going to perform backtracking. Check if path exists on right side, and recall method to the right. Check if path exists on bottom side, and recall method to the down. Check if path exists on left side, and recall method to the left. Check if path exists on top side, and recall method to the top. Thus the function recursively works and finally prints the path array. Time complexity of the code is big O of n, where n is number cells in the maze. It is same in worst case as well as average case. In worst case, algorithm visit each cell once until goal is found. The average is n by 2, although complexity of algorithm is still big O of n. Space complexity of the code is big O of 1. Actual space complexity of algorithm is big O of 6, in which 3 variables require 3 unit of space and 3 unit of space required for recursive call. Coming back to our example. Here the point 0 is starting point, and point 8 is the finishing point. Point 0 choose right path and move forward. Goes to point 1 modify arrays. Then reaching point 2 it realizes it is came to an dead end. Again it backtracks to point 0 and tries another path and modify the arrays. Like this the algorithm continues and reaches the finishing point. Finally it has reached the finishing point. So our final path to reach finishing point is 0, 3, 4, 7, 8. Conclusion. Backtracking solves problem by trying a series of actions. If a series fail, we back up and try a different series. A maze is a classic example, but the approach can be used on a wide variety of problems. Thank you.